Hello everyone. Today's lesson is about the atmosphere. What's the atmosphere? Atmosphere, it's the air that surrounds us everywhere. This atmosphere consists of a mixture of gases. Too many gases are mixed together. This mixture forming a layer surrounding Earth. This layer is kept attracted to the Earth and never escapes to the outer space by gravity. Now, this mixture, what does it consist of? What does it include? First, it includes oxygen gas, the first and most important gas. This is the gas that we breathe. Oxygen gas represents 21% from the total volume of the atmosphere. But the main question is, do you know why do we breathe oxygen and why we do not breathe any other gas? We are breathing oxygen and only oxygen because it's the only gas that helps in burning the food that we eat to get out the energy that our body needs. That's why we are breathing only oxygen. Then there is the nitrogen gas, which represents 78% from the total volume of the atmosphere. Can you see that? More than 3/4 of the atmosphere is only nitrogen. That's why we call it the most abundant gas, the most found gas. If I add both of them to each other, the result is going to be 99%. Can you imagine that 99% from the total volume of the atmosphere is just nitrogen and oxygen? Then the only 1% which is left is shared by all other gases, starting from carbon dioxide, which represents 0.03%, then a group of other gases. Carbon dioxide gas, which is representing 0.03%, it's still very, very important. Although it represents a tiny percentage and a tiny amount, but still very important for all green plants because it's one of the main components of the photosynthesis process. Do you remember that process by which all green plants can make their own food by themselves? Carbon dioxide from the air plus water and mineral salts from soil in presence of sunlight, forming out the oxygen gas that we need and the plants' food that they need. This process is very important, and without carbon dioxide, it can't be completed. Then there is a group of other gases, including hydrogen, water vapor, then a group of gases like argon, neon, krypton, helium, and too many other gases. So those are the main components of our atmosphere. Our atmosphere has a great importance for the human life. It plays a very important role in having life on Earth. What's that role or function? Number one, it protects Earth. It protects Earth from what? It protects Earth from the harmful radiation that comes from the sun. This radiation including ultraviolet radiation and infrared radiation. These harmful radiation can pass through the atmosphere because it absorbs it. So our atmosphere protecting Earth by absorbing the harmful radiation such as ultraviolet radiation and infrared radiation that comes from the sun. This harmful radiation, if it passes through the atmosphere and reaches to us on Earth's surface, it causes a lot of problems, starting from eye problems and skin problems. The second function is it adjusts Earth's temperature. You know, my dears, if the atmosphere allows all sunlight that comes out of the sun to reach us on Earth's surface, what's going to happen? The whole planet will burn. You know that? But our atmosphere, because it's smart, it acts as a one-way gate, passing only the suitable amount of sunlight that we need. So we can have a normal weather temperature. It's not too hot, so we will burn, and it's not too cold, so the whole planet freezes. So our atmosphere adjusting, okay, keeping Earth's temperature suitable for having life on Earth. Okay, so our atmosphere as a one whole layer, it has a very, very great importance for having life on Earth. Each gas by itself is important, but whole atmosphere is playing a very important function, which is protecting Earth and adjusting Earth's temperature. Now we have finished talking about atmosphere. Let's talk about each gas separately in details. Our first and most important one is our oxygen gas. We are going to talk about it in points. The first point is main source of oxygen in the air, which is what? The green plants. The only source of oxygen in the air is the green plants. That's why green plants has a great importance, and we have to increase green areas on earth because it keeps on doing photosynthesis process, and this what produces out oxygen gas in the air. Number two, the chemical formula or the chemical symbol of oxygen. Why do we have this? Because later on, inshallah, you are going to have chemical equations in metals department. You know that? So scientists found that instead of writing two long words for the names of chemical compounds, they can give them like contractions or symbols, okay, according to their names. For our gas oxygen, the initial of its word is a capital O. So then its symbol will be O2. O for oxygen. 2 to represent the number of atoms that each molecule consists of. So one molecule of oxygen consists of 2 oxygen atoms. It's okay? Now the amount. How much does it represent from the total volume of the atmosphere? Oxygen gas representing 21%. This percentage never increased or decreased. It's still fixed in the air. Why? Why the percentage of oxygen is kept fixed in the air, never increase or decrease? Because as long as we are consuming oxygen, as long as we are taking oxygen gas, whether during respiration or burning, it will be compensated or given back by photosynthesis process. Something like balance between taking and giving. Oxygen is taken or consumed by respiration of all living organisms and burning processes, whether the human burning that happens inside the human body for burning the food that we eat, or outside our body any burning process happens like burning piece of wood, paper, coal, or anything else. Any burning taking in oxygen gas, plus the respiration of all living organisms. So those are the two processes that keep on taking in oxygen. In the same time, green plants making photosynthesis and replacing what we consumed. That's why the fixed amount of oxygen is kept in the air. It's kept constant at 21%. Here we have an experiment to calculate the percentage of oxygen gas in the air. All what I need is just to fix a lighted up candle inside a basin containing colored water. Why especially we are using colored water? To be easily seen. Then I will put a cylinder upside down over the lighted up candle. Then I will wait for a while. Inside the cylinder here, there is an amount of air. This amount of air, it has an amount of oxygen. While my candle is lighted up, it will keep on using the available oxygen in the surrounding air. Till when? Till the amount of the available oxygen is finished. At this time, my candle will put off. When it puts off, this means that it has consumed all of the available oxygen around. So inside the cylinder, there will be a space, a gap. This gap representing the consumed oxygen. So an amount of colored water will rise up inside the cylinder up to a certain level. When they measured the volume of water that goes inside, they found that it equals 1/5 from the total volume of the cylinder, which means that the amount of consumed oxygen is only 1/5 from the total volume inside the cylinder. If I change this 1/5 into a percentage, it equals exactly or approximately the 21% of oxygen in the whole air. So like this, we have calculated the amount of the available oxygen in the air, and we found that it equals 1/5 from the volume of the air, which equals the 21% that we said in the beginning. Now let's see how can we prepare oxygen gas in the lab by using chemicals. Why do we need to prepare oxygen gas in the lab? We have it already naturally in the air, created by Allah. Why do we need to prepare it? We need to prepare it in order to use it in too many purposes for our daily life. For example, this oxygen, which is stored into the iron tanks, this is what we use whether in hospitals for artificial respiration or in diving or in climbing mountains. That's why we have to prepare oxygen gas by using chemicals in the lab. What are these chemicals that I need, or what do I need in order to prepare oxygen gas? There is only one chemical that's called hydrogen peroxide. This hydrogen peroxide, it can be dissociated. Dissociated means divided or decomposes into oxygen and water by itself without any interference from us. But it takes a very long time for hydrogen peroxide to be dissociated into oxygen and water. Actually, it's like 5 days. Wow, 5 days? Shall I wait every time I need to prepare an amount of oxygen? 5 days waiting for hydrogen peroxide to be dissociated into oxygen and water? That's too slow reaction. I have to do something. What's that thing? I have to add another chemical that's speeding up my reaction. What's that chemical? And a chemical that's called manganese dioxide. Manganese dioxide. This manganese dioxide, it just helps hydrogen peroxide to be dissociated immediately into oxygen and water. So all what it does, it just speeds up the reaction without any interference in that reaction. It's just a helper factor or a helping factor that helps hydrogen peroxide to be dissociated immediately into oxygen and water. So it fastens my reaction. But this happens under only one condition, which is what? Without any change in its quantity or properties. What does this mean? This means that the added amount of manganese dioxide in the beginning of reaction, it has to still constant even after the reaction, which means that it's not a part of the chemical reaction. It's just speeding it up. It will not join with the hydrogen peroxide. No, this will not happen. It just helps it to split it immediately into oxygen and water. And what proves this? That its quantity remains the same before and after the reaction. Added than above, that all of its properties also will keep the same. Properties like what? Properties like its color. If you saw this before in the lab, manganese dioxide, it's in the form of a black powder. This black powder remains as it is, okay, whether before or after the reaction. So all of its properties, whether color or form, which is a powder, also remains the same before and after the reaction. That's why we call this manganese dioxide a catalyst. Very important word, catalyst. What's meant by catalyst? Helping factor. What's the catalyst? Catalyst, it's a chemical substance that's speeding up chemical reactions under one condition, which is without any change in its quantity and properties. Okay, there is in chemistry a group of chemicals called catalysts. This family of catalysts including a lot of chemicals. One of them is manganese dioxide. And there are too many other catalysts, but we don't know anything about them till now. Okay, so catalyst, it's a term that includes all chemical substances that's speeding up reactions without any change in its quantities and properties. Like this, I have prepared oxygen gas. I put hydrogen peroxide over manganese dioxide, and at this time hydrogen peroxide will be dissociated immediately into oxygen and water. Now I have to collect what I have prepared. If I looked at the figure that we have in our booklet, that's the figure that we use in order to prepare oxygen gas. Here in this glass flask, we are mixing chemicals together. The black powder at the bottom, that's the manganese dioxide. Then hydrogen peroxide, which is in the form of a liquid. I will pour it by using that faucet. Faucet means tap. It's just like the water tap. When I open it, the hydrogen peroxide will fall over the manganese dioxide. When they are both mixed together, hydrogen peroxide will be dissociated into water and oxygen. Water will be kept inside the flask, while oxygen, because it's a gas, will rise up, pass through this tube until it's collected here at the top of this cylinder. at the top of the cylinder where more oxygen is formed as long as I keep hydrogen peroxide. As long as I keep adding hydrogen peroxide over manganese dioxide, more oxygen gas will be formed. So when the amount of formed oxygen increases, it will start to push water down. Pushing water down and taking its place. Pushing down means downward. Taking water's place means displacement. Replacing water until whole cylinder is full of oxygen. At this time, I will close it tightly and take it out and start to use it in any purpose I need. So how do we collect oxygen gas in the lab after preparing it? By downward displacement of water. We call this what? Downward displacement of water. Why do we use this way in collecting oxygen gas? Because this oxygen gas, which is formed at the bottom, never dissolves in water, hardly dissolves in water. So I will never lose my oxygen gas after preparation. So that's the only safest way for collecting oxygen after preparation, which is downward displacement of water. Give reason why do we use that way? Because oxygen hardly dissolves in water. And now let's see the properties of oxygen. Properties means facts about something. So properties of oxygen, those are the facts that we knew about the oxygen. They can be identified as follows. Number one, oxygen is colorless, tasteless, and odorless gas. It has no color, so we can see it. It has no taste, and it has no smell. Number two, oxygen scarcely or slightly or hardly dissolves in water. It doesn't dissolve in water, and that's why we are collecting it after preparation by downward displacement of water. Number three, oxygen gas doesn't burn. It never burns. It's surrounding us everywhere and it never burns, so it doesn't burn, but helps in burning. Any burning reaction happens whether inside our bodies like food burning or outside our bodies like lighting up candle, match, burning piece of paper or coal. Any of these burning reactions, they keep on working, consuming available oxygen in the surrounding air. Number four, oxygen is heavier than air as it replaces it. The molecules of oxygen are heavier than other molecules of other gases. Allah subhanahu wa ta'ala created it heavier to stay down, to be around us everywhere, so we can take it easily during respiration process. Number five, oxygen is combined by lighted magnesium to form magnesium oxide, which is a white powder. This is one of the most important reactions about oxygen. Oxygen can be combined with any other element, not only magnesium. Magnesium is just an element, just like iron, copper, gold, silver. It's just a name of an element. When oxygen combines with any other element, whether magnesium or anyone else, it forms something that's called oxides. Okay, so our example here is for magnesium. Magnesium, it's a shiny element. It belongs to the group of metals. It's shiny element and it has a luster. So when I just light it up by using a lighter, it starts to burn. And when it starts to burn, it starts to consume oxygen from the surrounding air. And when it starts to consume oxygen, they will combine together, forming new product I didn't have before. This product is called magnesium oxide. This magnesium oxide, it's not shiny element like magnesium alone. No, it's a white powder. So magnesium, when it burns and joins with oxygen, it loses all of its properties and start to form new material, new compound I didn't have before, which is magnesium oxide, and it's a form of a white powder. So those are the properties of oxygen. The importance and uses of oxygen gas. What are the difference between importance and use of oxygen? Importance of oxygen for all living organisms or to the human life means why it's that important, so we can't live without it. When something is important, this means that I can't live without it, no life without it. Why oxygen? We can't live without it because number one, Oxygen, it's one of the water components. The chemical formula of water is H2O. 2 hydrogen atoms and 1 oxygen atom. If this 1 oxygen atom is not existed, this means that there will not be water. And if there is no water, nothing alive will be. Allah subhanahu wa ta'ala said, وَجَعَلْنَا مِنَ الْمَاءِ كُلَّ شَيْءٍ حَيٍّ. So nothing alive without water. So if there is no oxygen, there will not be any water. And that's a very big problem. Number 2, oxygen, of course, is important for respiration of all living organisms. Human beings, animals, even green plants when they respire at night. Food burning also. We are, as we said in the very beginning, that we are just breathing oxygen and only oxygen and not any other gas, because it's the only gas that helps in burning. No other gas, Allah created it, helps in burning except oxygen. So we are breathing oxygen because this is the only gas that's going to help us to burn the food that we eat, so we can get the energy that our body needs. So oxygen is also important for respiration and food burning, and without oxygen, no breathing and no food burning, of course, no life. The second reason is ozone gas consists of oxygen. The ozone gas, what makes the ozone layer that surrounds Earth, this layer which is responsible for absorbing the harmful radiation. Do you remember that when we said in the very beginning that atmosphere protecting Earth by absorbing harmful radiation? Which part exactly in the atmosphere was responsible for that function? It's the ozone layer. Ozone layer, it's a layer that consists of too many molecules of ozone gas. One molecule of ozone gas consists of 3 oxygen atoms. That's why its chemical formula, it's O3. O for oxygen, 3 for the number of participating atoms in only one molecule. So one molecule of ozone consists of 3 oxygen atoms. So if there is no oxygen, there will not be the ozone gas. And if there is no ozone gas, no ozone layer, so harmful radiation will pass through the atmosphere and reaches to us on Earth's surface, causing all of problems that we talked about earlier. So the importance of oxygen, what makes it very essential, very important, so we can't live without it, are 3. 1, oxygen, it's one of the water components. 2, it's important for respiration and food burning. 3, ozone gas consists of oxygen. For these 3 points, oxygen gas is very essential and no life without it. Now let's see what are the uses of oxygen gas. These uses are just our uses for our daily life. We can use them or not according to our daily lifestyle. First, oxygen, when it's prepared in the lab, we can store it into iron cylinder. So we can use it in the all coming purposes. Number 1, mechanical ventilation, artificial respiration for those patients who are suffering respiration problems. And it's done, of course, in hospitals. Number 2, surgeries. During surgeries, all patients has to sleep by using medications. While they are sleeping during surgeries, they have to keep them on breathing. So they have to use also oxygen tanks with masks so they can keep on breathing during surgeries. Number 2, all divers and climbers, they have to carry oxygen tanks over their back. Why? Just to keep on breathing while they are just under water, or even while they are climbing mountains, because of course, you know, because oxygen is heavier than air, so all molecules tends to stay down. So when climbers climb 2 high mountains, when they reach up to the top of these mountains, the amount of oxygen decreases gradually as they are going up. So when they reach up there will not be enough oxygen to keep on breathing well. That's why they have to take oxygen tanks on their back while they are climbing up, because amount of oxygen decreases gradually based on the fact that says oxygen is heavier than air, so it stays down. Number 3, cutting and welding metals. You know, some people who's having like these guns, who's fixing cars or something, they have a gun by which they can cut any piece of metal into 2 pieces, then fix it and return it back to its original shape, then weld it together. Weld means joins 2 pieces of metals together. So oxygen is used in cutting any two pieces of metals into two parts or join them back again. How? By using that gun that you have here. Inside this gun there is a special gas that's called acetylene gas. So inside gun there is a gas. This gas is called acetylene gas. When I just press on that button, gas is going to go out of the gun, reacting with the available oxygen in the air, joins together. When anything joins with oxygen, it's forming oxide. So the coming out flame is called oxyacetylene flame. This oxyacetylene flame or acetylene oxide flame, it's too hot. Its temperature reaches up to 300-500 Celsius degrees, which is fair enough to cut any piece of metal into two pieces and join them again whenever I need. So again, cutting welding metals, it's one of the oxygen uses by which acetylene gas joins with the available oxygen in the air when it just comes out of the gun, forming a flame who's called oxyacetylene flame, whose temperature is 3,500 Celsius degrees, which is enough to cut and weld metals. So what are the uses of oxygen again? Mechanical ventilation, which is the artificial breathing or respiration, surgeries, diving and climbing mountains, and cutting welding metals. All these uses, I'm free to use them or not. So they will not affect my daily life like importance. So now we realize what's the difference between importance and use. Importance, something I can't live without. Use, something I can use it or not. Thank you so much. See you soon, inshallah.